Alright, so another math, easy solution. We're going to discuss inverse functions, and we'll look at part 2 of that series. Showed before what inverse functions were, but I didn't clarify on it. They need to be one-to-one functions, and we're gonna look at the horizontal line test to find this one. So what I mean by this is, if you have before what I showed that inverse functions. So basically, all the y and x values are switched. That's all it is. So I showed before, you can see that video, are switched. So basically, if you have something like y equals to f of x, so we switch them, and then we're basically solving for, so it would basically be x equals f of y. So that's basically what it is, but this also correlates to basically y equals f negative 1 of x. So this is an inverse function. So if you have something like this, so that's all it is, we're switching it. So if we look at the graph of a function, let's look at just a general function, y equals, this is yx. So we go graph like this, generally like that. So what I showed before, it's a reflection off of the y equals x line. This is called f of x. Let's just draw this y equals x line. We'll call this is the y equals x line. So this is just a reflection off it. The inverse is just a reflection off it. So we draw it perfectly like that. And we'll call this is the inverse of that. So you can see here is just a perfect reflection. So it's a reflection off, let's go y equals x line. So it's a perfect reflection. But now here's the problem is when we have when we have equations that are not one-to-one. So we'll look at one-to-one functions. So basically, one-to-one functions are, so if you have a graph like this, one-to-one functions means, so we'll go like, yeah, so what this is basically what it means. If you have y equals, this is yx, let's go f of x, and this is a horizontal line. What it means is, yeah, so what this means is that for one value of x, so for every x, there's only one, for every y, I mean, yeah, so for every y value, only one value of x. I'll show you why this is important. So basically, we would draw a horizontal line here. So this is a y value. So for all values of x, there's only one that hits the f of x line. So you would use a horizontal line test. So that's basically the horizontal line test. So basically, it needs to be one-to-one. I'll show you why. Let's look at not one-to-one. So let's look at the opposite. Let's look at opposite of one-to-one. Yeah, so basically, if it's not one-to-one, we'll have something like this. This comes in handy when we look at, let's just draw a sine function. Let's go with sine. So let's call this sine of x. So my video on how to graph them. So basically, it's a periodic one. It goes up and down forever. So basically, if we do a line test, a horizontal line test, we'll see that, well, yeah, so we see that with this horizontal line. Let's go horizontal line test. We'll see that for one value of y, let's go one y value has infinite x values. Infinite x values. So now this isn't one-to-one, so it's not one-to-one. So if we were to graph the inverse, if we were to do an inverse one, so we know it's a reflection off the y equals x line, so we'd go y equals x line. Call this y equals x. So that's the line. So if we were to reflect it off it, it would look something like this. So basically, yeah, it would go something like this. So I would draw it by itself to be a bit neater. Draw it by itself. So this is y. It's x or it's y. So basically what we have here is something like this. So we have something like this. It goes on forever. And this would be, let's say, so that's what it would be. But this is wrong. I'll show you why. So now if we have, so what this is saying now, if you have, let's say this is x equals, I don't know, 0.5. So then if we just graphed that, that's y equals sine, so inverse sine of x. So basically for, let's say x equals 0.5, then sine inverse of 0.5, this equals many values. So it's not unique. So basically, yeah, we'll have tons of values because it's basically inversely. Yeah, so basically if you do for x equals 0.5, you're going to have a bunch of these values. You're going to have this value, you're going to have this value. So you're going to have, yeah, infinite, many or infinite. So this is a problem here. So basically, so inverse is not defined for these. So inverse functions, you need one-to-one. Need one-to-one. Otherwise you can't do the inverse. And I'll show you my next video on sine. What we could actually do is for y equals sine x, what we actually do is restrict. So we restrict the domain of sine x. So here's just a preview of my next video. So basically what sine would be like this. So we would actually, yeah, so we would actually restrict it here. Whereas it would go keep on going forever. We would restrict it and then only look at this one, and then the inverse is going to be something like this. It's be something like this. So that's how the inverse will be. It will be something like this. So that would be f -1 of x or sine of x. So it'll look something else. I'll show my other video on how we're going to go around this requirement of inverse functions to graph inverse sine or inverse cosine or inverse tan. So basically, yeah, so it needs to be one-to-one, and you would do this horizontal line test is check. You just make a line and see if it hits more than one value. And then, yeah, so basically that's one-to-one functions. With a horizontal line, it only hits only one value. So yeah, it's basically that, and it's also a reflection of it. Yeah. So basically, this is just a little part 2 of that inverse functions to clarify it. Well, thanks for watching, and stay tuned for another math easy solution.